Hello, this is our last lesson on functions. We're going to be looking at the discriminant, find out what it is, and how it's useful for analysing a quadratic function. We've already able to analyse a quadratic function. We're able to find the y-intercept, we're able to find the zeros, or the roots, or the x-intercepts. We're able to find the vertex. Our focus just now is about the roots, and we're going to find out more about the roots of a quadratic. So let's begin. Here I've got three different parabola. We notice this one sits on the x-axis, so there's only one place where it intercepts, that's at -2. Here this parabola intersects the x-axis in two places, and this parabola doesn't intersect the x-axis at all. I've got three different functions here, and we're going to solve each one to find its zeros and look at the parabola. Each of them are of the form ax squared plus bx plus c. And so we're going to use a quadratic formula to find the x-intercepts. Here's our first graph. X squared minus 6x minus 4. We see there's an x-intercept occurring at A and at B. This is how we're going to calculate the x value at A, x value at B. We need to know the coefficients A, B, and C, so let's write them down. The coefficient A is 1, B -6, and C -4. Let's go ahead and plug those into the quadratic formula and see what happens. -b, -6 is +6, minus b squared minus 4ac divided by 2 times a is 1, so that's 2. Let's figure out what goes in here. B squared, -6 all squared, minus 4 times a times c. Let's take care of our negatives. -6 times -6 is +36. Negative, make that 52. So we have 6 minus root 52 all over 2, and that gives us minus 0.60. Well, it used to give us minus 0.606. And over here we have 6 plus the square root of 52 all divided by 2, and that gives us 6.61. Both of these correct to three significant figures. When we look at the graph, the value of a -0.6 makes sense to where it is located, and 6.61 again, that makes sense. So we use the quadratic formula in the way that we're used to find the two x-intercepts of the graph. We're now going to look at our second function g, which has the equation x squared minus 6x plus 9. Here let's identify that a is equal to 1, b is equal to -6, and c is equal to +9. Plugging this into our formula, we have -b minus b squared minus 4ac divided by 2 times a, which is 2. We've got the same thing going on over here. And what's in there, let's calculate that. -6 squared minus 4 times a times c. I'll make that 36, subtract 36, 0. So the left root has the value 6 minus 0 divided by 2, which is 3, and the right root has equation 6 plus the square root of 0, which again is 3. So both roots are 3, it's cutting at 3, so we call this one real repeated root. Okay, we're ready to look at our third graph, which has equation y equal x squared minus 6x plus 13. Coefficient a is 1, b is minus 6, c 13. Let's run this through the formula. We have 6 minus the square root of all that divided by 2a. A is 1, so that's just a. And over here we have the plus. Let's figure out what b squared minus 4ac is equal to 36 minus 4 times 1 multiplied by 13, which is 36 subtract 52, which is negative 16. So we'll put that in here, and let's see how that works out. So I've got 6 subtract, well, that's not something that we're permitted to do in the real number set. That doesn't have a real answer. And so we can't evaluate either side. And so we say for this one that there's no real solution to this, and as we see in the picture, there's no place where the graph cuts the x-axis. So in this case we'll say there's no real roots. This is where the higher level students will say there's complex roots, but there's no real roots. So let's summarize that. We found that there are 3 different values for b squared minus 4ac. On one graph we got our parabola that sat right on the x-axis, and that was when b squared minus 4ac was exactly 0. On another graph we got that b squared minus 4ac is cutting in 2 places. That happened when we had the number 52, so we had 6 plus the square root of 52 and 6 minus the square root of 52, giving us a left hand root and a right hand root. And finally we have the parabola, the flying parabola. This occurs when the number under the square root is negative, giving us no real roots to the equation. So let's summarize that with the equations we had. These were the 3 equations. On this one, b squared minus 4ac was equal to 52, and we had 2 real distinct roots. Here b squared minus 4ac was equal to 0, and we had 1 real repeated root, 3 followed by 3. And on the final one, b squared minus 4ac was less than 0, meaning the left hand root couldn't be calculated, the right hand root couldn't be calculated, so we say no real roots. Perfect. Let's apply that to 3 equations. So we're going to look at 3 simple equations, and then we're going to try some trickier problems. So the 3 simple equations, let's look at number 1. The coefficient of x squared is 2, the coefficient of x is negative 5, and the constant is negative 7. So when we calculate the discriminant, we find it is equal to 25 minus 4 which is 81, 78, 81. Importantly, that's greater than 0, so on this one we expect to see 2 real distinct roots, a left hand root and a right hand root. Let's look to see if that's the case. Here it is. Let's get rid of that guy. Here's our 2x squared minus 5x minus 7. That's what we were looking for. And here's the graph. There's a left hand root and there's a right hand root. So 2 real distinct roots. That's all we need to know. We're not interested what they are, we're just finding out how many roots there are. So yes, there are 2 real distinct roots on that parabola. Alright, let's look at number 2. The coefficient of our second parabola there is minus 1, coefficient of x is minus 1 and the constant is 19. So let's do b squared minus 4ac. We get negative 1 squared. 4 times negative 1 times 19. We've got two negatives there, so it's going to be a positive number. 1 plus 76. And that is 77. What's important is it's greater than 0, so expect to say two real distinct roots. Again, a left-hand root and a right-hand root that are different from each other. We've got x squared minus x minus 19. Let's have a look at that. There it is. Again, a left-hand root and a right-hand root. As expected, this is an upside-down parabola because we have a negative leading coefficient. But what's important is we have a left-hand root and a right-hand root, as we expected, because the discriminant is greater than 0. Okay, let's try the third one. The coefficient of x squared is negative 1, coefficient of x is 4, constant negative 10. 16 minus 4 times negative 1 times negative 10. Lots of negatives to keep us on our toes. 16, 4 times 1 times 10, that's 40. Negative times negative is positive, times negative is negative. So 16 minus 40, subtract 40 is negative 24. And what's important is that's less than 0. So our discriminant value is less than 0, meaning we're going to be taking the square root of a negative, which is something we don't have a real answer to. And so we're going to expect there to be no real roots. In other words, a parabola that looks something like this, or like this, or like this, or like this. Let's have a look. It's got a negative leading coefficient, so it's one of these two. Let's see. And here it is. Negative leading coefficient, and it's a flying parabola. It doesn't cut the x-axis in any location. That's what we expected because the discriminant is less than 0. We're ready now to try some trickier problems. Here I'm going to write the solution to number 2 and number 4, and the rest is an exercise that you can find on PureNet. The exercise and the solutions are all there. On these questions, we're not told the coefficients of the quadratic expression. We're told how many zeros the equation has, how many solutions this equation has. So this has one solution that's repeated, and we've got to figure out what that number there is. So the discriminant is going to help us solve that. Alright, since it has one repeated root, we know that b squared minus 4ac is equal to 0. In other words, when we draw this parabola, it's going to look like that. So there are some values of b, values of b that are going to make that happen. We'll find out what values will work. A is 2, b is just b, that's the thing we don't know, and c is the value 50. And we calculate b squared minus 4ac. We're required equals 0, so that it sits on the x-axis. And so we find that b squared is 400, therefore we know that b is equal to 20, or b is equal to negative 20. Those are the two solutions to this equation, meaning that if I draw the parabola y equal 2x squared plus 20x plus 50, or if I draw the parabola 2x squared minus 20x plus 50, both of these will sit on the x-axis. Let's have a look to check that out. Here's the first equation. Here's the second equation. Both equations are sitting on the x-axis as we expected. Okay, our final question for this video. There's no real roots. This is a trickier question. It's going to ask us to be able to understand this concept that when you have a parabola, some values are above the x-axis. Those values are positive. And some values are below the x-axis. Those values are negative. These negative values occur for these x values, and the positive values occur when the input to the function is in this region of the x-axis. So these values of x will yield a positive answer. These values of x yield a negative answer. If you're good with that concept, this question is going to make more sense. Okay, so no real roots. That means that b squared, the discriminant, is negative. In other words, we're looking for a negative number under the square root. And that will yield a flying parabola. Here we have the coefficient a, b, c. And substituting in, to b squared minus 4ac is less than 0. Let's multiply out those brackets. K plus 1 multiplied by k plus 1 gives us trinomial. And so here we have k squared plus 2k minus 3 is less than 0. This looks like a reasonably straightforward expression that we can factor. Something to do with k and 1. I need plus 2. So let's go for plus 3 minus 1. And the graph of this parabola is going to help us solve this inequality. It's a quadratic inequality. We have to be careful with the quadratic inequality. So to help us to solve it, we're going to draw a graph that has a y-axis that we're familiar with, and not an x-axis, but a k-axis. So this is going to be an expression for y about k. We're going to draw the graph y equal k squared plus 2k minus 3, and we know the critical values. Occur at k equal negative 3 and k equal 1. So let's put negative 3 there, 1 here, and it has y-intercept negative 3. So let's put that on down there too. And let's draw our parabola. Something like this. Okay, so these are the values of k squared plus 2k minus 3. Shown here, this is the k-axis, this is the y-axis. And we see that these values are positive over here for these values of k, and over here for these values of k. The expression k squared plus 2k minus 3 is negative in this part of the graph about k. In other words, between negative 3 and 1, when k is between negative 3 and 1, the answer to this expression is negative. So that gives our solution. We're required to find the answer to this to be negative less than 0. That will occur when k is between 1 and negative 3. Let's make sense with that with a graph. And so here I have this graph is made up with x squared plus k plus 1 x plus 1. And I've got a range of values for k. And what we've just said is, as long as I take k between negative 3 and 1, the parabola will be a flying parabola. There it is, above the x-axis. When I go beyond that range for k, I'm going to cross the x-axis. Go beyond it here, I'm going to cross the x-axis. So for any value of k between -1 and 3, the parabola is a flying parabola. There are no real roots. b squared minus 4ac is negative. And that's our answer. Okay, so just to return to this worksheet, there are 6 other problems that you can tackle, which are similar to the one we just calculated, number 4, and the solutions you can find on PureNet. I hope you found this video helpful. Enjoy the rest of your weekend.